Hi, I just putting together a little presentation on the work that was done at the Townhomes of Old Nutana for the ice dams that we did during the summer. Like Rick and I were working on them, and then completed in finally in the middle of December. So I'm just going to go over the product, what was used, and more or less how it works. So this is my first crack at doing a presentation, so bear with me. I hope there's not too much motion sickness. Okay, so starting out, like what you should see, this is a picture of what was taken last year when we had ice damming, and this picture is just off of my deck, and this faces Victoria Avenue. You can see under the eaves where there's a considerable amount of ice, and this is not a good thing. That ice builds up, and then when it does melt, it can actually melt into the walls, causing all sorts of damage. So that's pretty much what we were up against. That's one zone where we're having problems. In total, there are 6 zones. So this is just zone 1. Kind of keep that in mind, so when I move along, we can see what's going on. We looked at solutions for this, and Rick and myself. Rick had some experience in a place where he had lived before, one of his properties, and with ice, like de-icing ice dams. I was familiar with a company out east that I worked before on a different project. So Rick and I talked, and we approached the company in Ontario, Canadian company, and we brought our concerns with them, and they helped us with the engineering of our project for ice dams, Townhomes of Old Nutana. Okay, on this page, it's called the edge cutter, and you can see in the picture, like I'll move my mouse, where it's the ice does or the snow has melted, and obviously that's where it's heated, and then it melts into the eavesdrop. And going down, this right here, this picture is extruded aluminum. It's about 7 inches wide, and your heat cable goes into the edge of that extruded aluminum, and then this piece here gets strapped over. When there is power turned on to this cable, the cable gets hot, and the heat travels up the extruded aluminum. So you just don't have heat where the cable is. You actually have heat where the aluminum is, and this aluminum is placed underneath your shingles on your roof edge. I'll take you this picture right here. So you can see right here, like basically that's where your extruded aluminum is underneath. So it's underneath there. That's why you see like shingles, and you have a snow line, and that's how it's supposed to operate. There's videos if you're so interested on how it works. I'll just play this video for a bit. Bear with me.
Welcome to Heatline Freeze Protection Systems.
I'm going to fast forward through it.
Eliminate damage from ice dams and dangerous icicles with Heatline's remarkable edge cutter roof.
That's a picture of how the cable.
Heatline self-regulating electrical paths between.
This is a picture of how the cable is constructed, and that's what goes into the
parallel bus wires at every point along their circuit length. Heatline self-regulating heating cables automatically adjust heat output at each point microscopically along their length. Heat is supplied safely and efficiently when and where needed, increasing heat output with cold and decreasing heat output with warmth. They will not overheat and can be installed on a variety of roofing materials.
Here we go.
Edge cutter is an aluminum flashing designed to be used as a heat conductive plate to aid in keeping snow and ice away from roof edges. The system is for use only with self self-regulating heating cables certified for use in roof and gutter applications. Edge cutter is applied between the roofing and roof substrate. It can be used with various roofing materials including asphalt shingles, aluminum, steel, and even slate. Prior to installation, determine the layer desired and clear the roof, leaves, and other debris. Carefully peel back roofing material, exposing the roof substrate. Proceed to install the edge cutter flashing only. Do not install channel caps until later in the installation. Once the channel caps are installed, they cannot be removed. Install the edge cutter flashing to the roof substrate by using appropriate fasteners such as screws and/or roofing nails, flexible adhesives, or a combination of both. Complete the edge cutter across the entire leading edge, requiring roof de-icing. Provide a quarter-inch spacing between flashings to allow for expansion and
six
contraction.
times, 6 zones. On a 3-story building.
Edge cutter can be installed in valleys and other locations. Please consult the installation manual or a heatline technician. The flashing installation is now complete. Allow the adhesive to fully cure before proceeding with the heating cable. Once all the edge cutter flashings are installed, sweep the channel area clean and lay the heating cable within the channel. When installing the heating cable, be careful not to tug or pull across rough or sharp edges. Care should be taken not to damage the outer jacket of the heating cable.
Seeing as how it was 3 stories up and we have to go in the attic to run our power lines.
When laying out the heating cable, provide drip loops where necessary. To install the channel cap, first position it by fitting the top barb first, then snap the channel cap down onto the bottom barb.
All that easily.
Lay out the entire heating cable before snapping the caps in place. Once caps are installed, they cannot be removed.
See that heating cable running back down the gutter?
After the heating cable has been installed through the edge cutter, continue into the gutter with a single pass, extending all the way to the opposite end of the gutter and into the downspout. When heat tracing downspouts, a special downspout hanger bracket should be used to avoid any mechanical damage to the heatline heating cable system. For more than 25 years, Heatline products continue to provide unmatched performance, efficiency, reliability, and product longevity.
Being heated.
Always refer to the installation guide for full installation steps.
And everything will melt.
Heatline Advanced Heating Cable Systems. Expertise.
Okay, so that's enough of that. And so now you're familiar with the product that we're using. So the next shot will be, this is a control panel that had to be fabricated to operate six zones of heating. Like you can see here, like in this panel, you got zone 1, zone 2, zone 3, zone 4, 5, and 6. This one here is a control that brings on the light in the parking lot. So that's we can time that on and off. This here is a duty cycle timer control, so we have the ability to run, 80% on, 20% off by playing around with these settings. So below here, there's like 6 relays. These relays bring on power to the heating cable on the 3rd story, all 6 zones. Two of these zones are like 240 volt. And the other 4 are 110 volt. This is when I was just getting it all commissioned. So that is in Lisa's garage. It's turned out pretty good. The door's closed. It doesn't look gaudy or anything. A sub panel will have to be added, and that takes care of that. So I'll move along here to some. This is the product that we're using. So this. Those 6 switches that I showed you that bring on the zones, they're a Leviton switch, And we control those zones by time schedules, on-off commands with an app through the phone, through an Android device, be it iOS or Android. And it's also there's a web-based site you can go to and do the same thing on your personal computer. So that's basically like when you're looking at that picture, you can see this is the app on your phone, and it's just been turned on. And then I'll talk more about that later. This this is what we're using to monitor the electrical consumption in our for our edge cutter zone heating and anything that's tied in that panel. Uh, this panel sub panel is tied to Lisa's main panel, so we have to calculate the costs from running this equipment, and then obviously do a calculation, and Lisa will be compensated for her electrical bill, because her electrical bill will be higher, obviously, because there's more of a load. Right here is this is the sense control monitor that's put into the panel, so it has the ability to monitor in real time and wattage exactly what's being consumed. So it's Wi-Fi, and it goes on to like we're able to hook up onto the web with that. Even if we lose power, we still this thing. If we lose the Wi-Fi signal, this thing will still keep on ticking, and it has the ability to keep taking readings for apparently 3 months even without a Wi-Fi signal. So what's ever being consumed, you can go back and retrieve that data for billing purposes and just for records. So that's the panel. So the next shot here is, okay, this is after it's all been hooked up. This picture was taken from off my deck on third floor. So what you're seeing here is the cable on top of the roof gutter, and that which is heated, and also underneath, like this is where that aluminum extruding is, and it's also being heated. So like any melting that's going on, like it melts, goes on to the roof gutter eaves drop, melts, goes into the gutter where it's heated all the way down to the ground through a downspout. So everything leaks out onto the ground. So we're not plugging up the gutters or leaks. So you can see how that works. So there's no snow here. We're keeping that snow line up above, so we can't. What happens with an ice dam is it melts, and then that snow, without the heat gutter, like heat trace tape, like it keeps melting, and then it will hit this cold aluminum eavesdropping, where it's it's not heated, so then it forms ice, and then you get an ice dam. So that's and then these things can build up to 1 or 2 feet because it just keeps melting. So with this system, you can see that if there is anything melting, it'll go down, and then that the moisture water will be taken down the downspout, and then we won't have ice dams forming. Okay, see what the next picture's all about. Okay, so this picture here is a thermal imaging picture of the picture that we just looked at before. So what you're seeing here is the heating cable that's embedded in that aluminum extrusion, and so like it's quite, it's hot, and then that aluminum is heating up. So like this area here is all being, like, heat is being transferred from this cable through the aluminum, and then you can see where it's heated, and that's why there is no snow in this picture right here, because it's all heated. With a thermal imaging camera, it's a good tool for commissioning these projects and finding out if what you have done has actually worked. So this is proof yet. Okay, so what I want to do next is show. Okay, this is an these are the apps that we're using to control our 6 zones of heating, and this is the app right here. This is I'll show you how this works. So we come into this app, and then we have these devices we can click on or off. You can see I'm clicking it off. Okay, they're not green anymore. They've gone off. I'll turn them back on, and so also see if I can move me. So schedules. These are schedules that I'm working with to turn our devices on and off. So I'll go down to the bottom here, and this right here I have 3 hours on, 3 hours off. So like I'm running at 50% of the time. So you can see 6 a.m. in the morning, it runs till 9 a.m. Then then it's off from 9 a.m. to 12, and then there's my 3 hours off time. Then I'm on 3 hours on time, 12 p.m. to 3 p.m. Then off for another 3 hours, and at 6 p.m. It comes on. 9 p.m. it goes off. And then it doesn't come back on until 12 a.m. in the morning, and goes back on or comes on at 12 a.m. in the morning and shuts off at 3 a.m. in the morning, where it just goes through a cycle again. So we'll shrink that back down, or I'll go to home. I'm back to my pages here. So it says I have 6 devices on and 5 devices off. Somehow I managed to hook up my some of my personal lighting in my home, which is doesn't interfere with any operation. It's just just the way it worked out, and it's just easier for me to do this rather than bust up into two different residences. So I'm keeping it all in one residence. This parking light here, that's the actual light in the parking in the back in the alley, and that's brought on through a scheduled, and we can run sunrise to sunset, or we can put a schedule on it. We actually have an outside plug that we can turn on and off through this application. So if we wanted to in future to use that plug to power up something that we're using, let's say, I don't know, like Christmas lights at Christmas time, we could use this plug, put it on a schedule, and then run it time, and then we're able to attribute the cost, know how much it costs to run the Christmas lights and all that. So I kind of did that for the future. So I guess it's always something to think about. Okay, so what I'm going to do now is shrink this window back down. We're kind of working with a split screen. I'm going to log into to the Sense. All right. So this Sense monitor is actually that device that monitors the electrical energy, and we're able with this hardware to in real time to figure out our costs for operating the system. Just to show you how effective it is, I'm going to shut everything off. So watch this number here. Like can't really get it. Okay, the bigger. These are in watts. So okay, let's turn it off. So bang, I'm turning it off. So as we're turning these devices off, you can see the power consumption going right down. We're basically down to 14 watts. That 14 watts, that's the power that's forever on, and that's the power that those switches use to consume, because the switch is always on and it commands things on and off. Like I'll turn the outside plug on, and just to give you an idea how that works, like I turn it on. See, it went up by 1 watt. So that's pretty accurate. Like just to turn the plug on takes a 1 watt of power. So I'm going to turn my devices back on because what I actually have done is interrupted the schedule. So here I go. There's zone 1 coming on. There we go. Things are happening. See, I turned zone 1 off, so it dropped off right away. I'm going to turn zone 1 back on. You should see an increase of power. There it goes. Like it went to 4,000 or whatever. So I'm going to start turning these back on to where they were because and let the schedule these on and off. So you can see in real time how this works and helps us operate those 6 zones of ice melting systems. So this brings an end to my little presentation, and I'll be forwarding it out. Any questions, like you can give me a shout. Bye for now. Just got to figure out how to shut this thing off.